Good morning, students. So today we're going to solve question 28 from GATE CSE 2024 set 1. The question states that consider a circuit shown below where the gates may have a propagation delay, right? Propagation delay is a concept in digital logic which means that the gates, change in input of the gates would result in a change in output after a small or noticeable, or at least not noticeable is the wrong term, basically a measurable amount of time has passed, right? So the change in input will lead to a corresponding change in output, but there would be a time delay between them. That is what we call propagation delay inside of gates. Now that is given for the question that there may be a propagation delay. Now they says that assume that all signals are basically these parts. X is a signal, right? Y is a signal, right? And signal can only be of 0 and 1. So transition inside of signal means from 0 to 1 or from 1 to 0. That is signal transitions occur instantaneously, and the wire has no delays, and the wires have no delays. Okay. Which one of the following statements about the circuit are correct? Are basically means that this is a MSQ type question, multiple select type question, and correct means that we have to select the options which are true, which are true and have a truth value true, right? So let's read the options. The first option states that with no propagation delay, the output Y is always logic 0. B states that with no propagation delay, the output Y is always logic 1, right? So this states that Y is always going to be 0, and this states that it is always going to be 1. Both of them deal with no propagation delay, right? And option C says that with propagation delay, D states with propagation delay. So option A, B are of one category and C, D are of different category, right? So let's analyze the circuit in which there is no propagation delay, right? So with no propagation delay being present, that means that after the input has been provided to the logic circuit, the output is produced instantaneously. That is, there is no time is required for the stabilization of the circuit, and as there is no delay is present in the gates and or the wires, so obviously the output will be instantaneous. That is the only logical conclusion, right? For 0, the input to the two gates is going to be 0. The output of NOT gate is going to give us 1. The AND gate is fed with 0 and 1. As you can see from the truth table of AND gate, if any one of the inputs of AND gate is 0, the output of that AND gate is going to be 0, right? Otherwise it is going to be 1. That is the behavior of AND gates, right? So as one of the inputs is 0, the other input does not even matter. The output is always going to be 0. That is the way it is for X to be 0, and for X to be 1. The one of the inputs is 1, the other input turns out to be 0 because NOT of 1 is 0. So as one input is 0, the output is 0, right? Now you may say that what about transitions from 0 to 1 and 1 to 0, right? From 0 to 1 and 1 to 0, the transition are not going to cause any problems, as we have already basically assumed that there are no delays. As there are no delays, there is not going to be any any state that is going to be in between. Or any amount of time is required to stabilize the circuit's output, right? So the output is, if the output is 0 for both of the cases, then even during transitions it is going to be assumed as 0, right? So the output is always going to be 0. That is the correct interpretation of the question. Now the first option states that part, so that is why the first option is correct, has a truth value true. The second option has a truth value false because it is the opposite of first, so obviously it is false. Now let's come to option C. Option C states that with propagation delay, the output of Y can have a transient logic of 1 after X transitions from logic 0 to logic 1, right? So when X is transitioning from 0 to 1, Y can have a transient logic 1. Y will become 1 for small amount of time, right? D states that with propagation delay, the output Y can have a transient logic 0. Output can have a transient logic 0 for a very short amount of time because it is transient logic, right? After X transitions from 1 to 0, right? X transitions from 1 to 0. That is the case which is being presented. Now our analysis till now showed that y always tends to become 0 when the whole of this logic circuit stabilizes, right? But here in option D they are suggesting that y is becoming 0 for a transient logic, I mean for a very short amount of time, right? So the opposite part of transient logic is that normally it is 1, right? So that assumption that the D option is stating that y is going to remain 1 normally and will become 0 when this transition from 1 to 0 is happening is completely false, as we have already done analysis for that, as the stabilized state for our y is 0. So hence D is wrong, its truth value is false, right? D is wrong, its truth value is false. Now coming to this, for transition 0 to 1 of x, what is going to be the value of y? Let's see. So for when our value of x is 0, this is the case, the output is 0 and this is the logic that is flowing, right? With that, when 0 becomes 1, the input that is fed to the AND gate is going to be 1 and the input that is going to be fed to NOT gate is also going to be 1. Right now, mind you, the output of NOT gate is going to take some amount of time for it to produce the output, right? For it to produce the output. Now, this is actually a very good example here. Now, for small amount of time, both of the inputs of AND gate have become 1. For that, the output is 1, right? For that, the output is 1. So, y is going to become 1 for small amount of time. Obviously, there is going to be some delay because of the AND gate. But after that, y is going to become 1. And as the output of NOT will become, make the second input of AND as 0 after a small amount of time, then as one of the inputs has become 0, the output will then again, after again short duration, will become 0 again. So as you can see, for a transient amount of time, for a short amount of time, while a transition was happening, namely from 0 to 1 of x, the value of y would become 1 if there is a propagation delay, and that is exactly what the option C is stating to us. So option C is actually true. Option C is actually true, right? And obviously maybe you would not have been able to visualize this very well. I would suggest that you draw this diagram with your own hands, then you would be able to understand better. To provide you with better visualization, I have created a small animation. I will show you that just after this. But with our analysis, the answer for this question is A and C, right? Okay, so now I am going to show you a small animation that is going to help with your visualization of this particular condition that is happening, transient state of y becoming 1, right? When your x is changing from 0 to 1, right? That is what I am going to show to you, right? So with 0, I have already shown that the output becomes 1, the output becomes 0, right? This part we all understand very well. Now let's move on and let's change 0 to 1, right? It becomes 1. So 1 is being fed to both the input of the gates. Now, right now both of them are 1, mind this part, right? Both of them are 1. The output of y is still 0 because it is taking time for the output of the AND to change, right? Now the output of NOT has already changed and the output of AND has still not changed, right? Is possible, okay. After that, the output of AND changes. Right now, see, both of the inputs are 1 and 0. For this, if there was no delay, the output would have become 0. But as there is propagation delay, hence AND is going to become 1 here. And it is going to stay 1 for a small amount of time. Then it is going to become 0 again, right? This is what is actually happening over there, right? I hope that this thing actually gave you a better visualization on the topic. Obviously, drawing with your own hand is the best way, but this will help you understand it even better, right? And with that, guys, I really hope that you must have learned something new from this video, or some of your concepts must have been revised. If you like the video, like and subscribe to the channel, share it with your friends, and have a good day. Happy learning. Thank you.